So here we're going to take a look at the code for the first objective on the SquareBot, the MazeBot project here. So here, let's see if it focuses. There it is. So basically what it does is just like any other time we're using the MEC controller. We attach all of our libraries and define our different pins for the LCD display. Then right here we designate the motors as left and right motor because we move the left and the right motors independently so we can steer. And we actually attach them on the appropriate pins. Then down here is just the pins for setting up the backlight and the such on the LCD display. Excuse me. And basically we just go and set these different lines of code that stay on the screen. We have AACC Mechatronics, the Vex microcontroller, and then bot status, and we'll get to that in a minute. Let me scroll down here. So that's the setup portion of it. So the void loop part of the code is fairly long. So this is the first part where we control the robot completely through programming. So basically it's just a lot of repetitive code telling it to print the command that it's doing, whether it's stopped or it's running, and then all we do is give it so we start off with a delay time of 5 seconds just so that you can turn the switch on and move away, and then we just say make the left and the right motor go forward at the same speed. Do that for 6 seconds. And then from there, we make a 90-degree. Well, actually, we pause for a second first. I do that in between each movement just to make things go a little smoother. And then we just do a 90-degree turn to the left for 2.5 seconds, and that makes a perfect 90-degree turn. And then we just do different combinations of those different movements to make it through the course. You see how long this is here, and then gets to the end and then stops. Does a 10-second pause so you have enough time to get in there and cut the switch off to make it stop. So now I'm going to talk about the physical design of the robot, the MazeBot here. Now, unfortunately, I got a little ahead of myself and decided to take the whole thing apart before now when I'm recording these videos. So I have to kind of make do here. I have the instructions for the SquareBot pulled up here because that's going to be the best way to explain it, because I pretty much just copied the instructions for the SquareBot almost exactly. It made a few changes, of course, but it's almost exactly the same. So it uses the overall frame and architecture and gearing, all those kind of things. They're exactly the same as in here in this picture of the SquareBot. Let's see if I'll scroll up here and see if there's any better pictures of it. Now, obviously, like I said, we made some changes to it because of the course that we used here. This might be a little bit better picture. Because of the course, especially with the ramp portion of the course, with these small wheels that are on here, the large driver gear would hit the top part of the ramp. I think everybody had that problem, so the way I solved that was by putting on those big, huge wheels that you can see in the video when it's navigating the course. So those were kind of a challenge to put on, because if we just put them on the shaft as these are, they'll hit each other in the center. So I had to stagger the wheels so that they didn't rub on each other, and had to put extra long shafts on there, and looks kind of ugly, but it works. The other major design change from this, and of course everybody had the same in the class had the same thing, was that the controller is different. I don't know what controller they're using here, but the one we're using is the Mega controller, obviously, so we have to make some design changes there, but I think everybody pretty much had the same design for that, more or less. Otherwise, it's almost exactly the same. Just have the plate up here in this diagram that holds the battery, and then, so of course for the first objective on the SquareBot, or the MazeBot, sorry, it's just the plain robot itself, no sensors or anything. And then for the second objective, I did not use the bumper push buttons. I used the I guess they're limit switches, the switch with the longer metal arm on it. It's a little easier to press than the push button. They seem to be a little more sensitive. Plus they got out a little farther, because I had my wheel sticking out so far. I needed something that would hit the wall before the wheel did. But yeah, that's the basic design of the robot. Again, it's 95% similar in design to the instructions here for the SquareBot, but of course with a few notable changes. Alright, so now we're going to go ahead and look at Objective 2 here. Now, of course, it starts off basically the same way. The only difference is that we have these two integers up here. The switch. The switch is the left and the right hand bumper switch. And I'll explain those here in a minute. So this is the same thing. We just tell it left and right motor, all these different things here. It's the same as any other thing. The only other thing that is different is these pin modes here. I have an input pull-up on pin 2 and 3, and again, that's for the switches. And I guess I'll go ahead and explain those now. So the way this code is instead of like the last one, where we're programming the movements, this should be able to navigate the course by itself. And the way it does that is by using two different switches to bump. Essentially what it does is it hits one of the switches and says, okay, there's something on the left-hand side. So it senses that, so it stops, it backs up a little bit, makes a slight turn in the opposite direction. So if it hits the left-hand sensor, it'll make a slight turn about 15 to 20 degrees to the right, and then starts moving forward straight again. And if it hits something again on the left-hand side, it'll do the same thing. Back up, turn a little more, try again. Similar thing if it hits something on the right-hand side, it backs up, turns a little to the left, starts moving forward. So it should be able to navigate just about any course in theory. In practice, it doesn't quite work as smoothly as I'd hoped, but it seems to work fairly well. So anyway, back to the code here. We have it starts off just by moving forward straight. It takes a read on. Oh, I just moved out of the way here. There it is. It does a digital read on both the switches, and then takes puts an integer So the opposite, because of the input pull up, we have the opposite of the red value. We turn that into an integer called left switch or right switch, and then we go in here into the if statement. So remember that we're moving forward while this is happening. So it says if right, so if the right switch is high, or I suppose low, but if the right switch is pressed, first thing that happens is it'll print on the serial monitor. It'll print right obstacle. And what happens is the first thing that happens is it stops. It prints obstacle on the LCD screen. It will then print 90, because 90 is the stopped value on both of the motors, and it'll pause for a second. Let's see if we can get it to focus again. There it is. So then the next step is it backs up for half a second, and again it prints reverse to the LCD screen. I can't seem to get this thing to stay focused. There it is. It prints reverse to the screen, and it also prints the speed, which, because the motors are in the same orientation, they have to work opposite of each other. So 70 on one motor and 110 on the other. And then it will do a very slight right turn. It'll only turn for a second, 0.1 second, tenth of a second. So again, that's a very, very slight, about 15 to 20 degrees turn. And while that's happening, it prints avoiding to the screen, LCD screen. And then after that happens, it'll continue moving forward, because we still have that initial forward movement that is sort of overriding all else. And then continuing on our if statement, it has the same thing, but it all works in the opposite manner. All the movements happen to the right instead of the left. But overall, it's basically the same. And then so that's the end of the code for the objective 2, and it'll just keep on moving forward. The major problem with this setup is that it doesn't really stop. It just kind of gets to the end of something. If you were to get it into a box, essentially, it would just kind of sit there and fight with itself. It would hit one bumper, move a little to the left, and you could either get it into moving in a circle, or it could just start moving back and forth, move left, move right, move left, move right. So, like I say, it's not perfect, but it seems to navigate fairly well.